Okay, this podcast is part one of two podcasts focusing on the binomial distribution. The binomial being, again, a nature of two things. So there's the likelihood of success, namely p, and that so-called probability of failure, which would be 1 minus p. So in your formula booklets, you'll see this combinations formula. We'll bring that alive in a few minutes. And the reference you see to binomial distribution, this will actually be something we look more specifically at in part two of the binomial distribution podcast. So let's look at a classic example where students at a school are surveyed and 72% favor the elimination of final examinations. A random sample of 5 students is then taken from the student body. We'll focus first on part A, namely the likelihood that exactly 3 students are in favor of eliminating final exams. You can see the binomial flavor. Either you are in favor of eliminating final exams or you're not in favor, right? So you'll have the probability of being in favor as given is 0.72, and the probability of not being in favor is low at 0.28. It has to be 1 minus that. So looking again just specifically at exactly 3 students who might be in favor of eliminating exams from that sample of 5, I've mapped out some details here that really pull apart what we're trying to get into for the understanding of what will eventually be a very formulaic way to approach this with almost exclusively the use of the GDC. But to teach to the understanding of it, let's say of the 5 random students sampled, let's say for case 1, the first student is in favor of eliminating exams, the second not, the third happens to be in favor, the fourth not, and the fifth is in favor. So here's a way of having 3 students out of 5 being in favor of eliminating exams. Well, there's more to the story than that, right? Maybe of the 5 students randomly sampled, maybe that first student was not in favor, the second and third were in favor, and the fourth not in favor, where the fifth was in favor. You get the idea that there's a number of cases here. And so trying to track that number of cases is almost exclusively not expected at the IB level because there are just too many. And as it turns out, there's actually 10 different cases you'd have to pick up. But again, you don't need to worry about highlighting all of those. This is just trying to get into the understanding of the concept. So this number of possible combinations provided by this algorithm in your formula booklet is saying how many ways can we combine R out of a total of n. So how many ways can we combine 3 of those students out of the 5 selected? Well, utilizing that algorithm gives us that there's exactly 10 ways to do it. That's what this hands us for free. So there are 10 of these different combinations here in different cases. We're going to look more closely at case 1 because when it comes to each of these respective cases and the probabilities that are involved, well, you can kind of see a probability of A and B kind of flavor to what's going on here, where it's actually the probability of first and second and third and fourth and fifth, and that's going to end up leading to some multiplication. So we'll look more closely at what's going on here on the next slide. So the probability that the first is in favor and the second is not in favor and the third is in favor and the fourth is not in favor and the fifth is in favor, well, that's just sort of an expansion of your probability of A and B formula, which says multiply all of those probabilities together. Well, you can see here, here, and here, those are your 0.72s, and here, those are your 0.28s. And so you've got 0.72 actually showing up sort of 3 times and 0.28 showing up 2 times. So there's 10 sets of those, because if I went back here and looked more closely at this second case, same exact thing, right? You got the 0.72 3 times and the 0.28 2 times, et cetera, et cetera, et cetera. So there are actually 10 sets of those. And you'd be saying, well, it's going to be, for example, this possibility or this possibility and where you've got something, the probability of something or something else, that's going to mean the addition of them. So you'll be adding all of those together, which of course is the same as just multiplying one of them by 10. So finally, if we're letting the random variable x be the number of students in favor of actually eliminating exams, the probability that x is exactly equal to 3 is the number of ways we can combine those 3 out of 5 times the likelihood of, here is your p, here's your 1 minus p for success for those 3 to the non-people that don't favor the elimination of exams, and you end up getting 0.293. This was intended to get inside of the understanding of what's going on as to why the solution with the GDC is going to make perfect sense. And again, you will almost exclusively be doing these questions using the GDC. So let's get the same exact answer using technology. So again, same question. We're talking about 3 students in favor of eliminating exams out of the 5 selected. If you go second VAERS, you can see in blue, distribution is what that stands for. So when you click on second VAERS to get the distributions, to get access to those different levels, this menu will come up. You're going to scroll down. And today, with this podcast, we're focusing on not only the binomial PDF, we'll do that in just a sec, but also the so-called binomial CDF. The PDF is concerned with exactly one place because we're talking about exactly 3 out of the 5. So when you click on the binomial PDF, you get a menu, hopefully, that looks like this. Some of the older operating systems are not as user-friendly. We'll talk about that later if need be. The number of trials, which is 5 because you're sampling 5. P is the likelihood of success of 0.72. You input that. The x value is 3. And then when you enter on that, you get a paste opportunity. You enter again, and this should come back to the home screen, which is a binomial PDF because we're talking about it exactly at one place. And that's different from a CDF, which will be a cumulative nature. And we'll do that in just a sec. So when you enter on that, boom, there it is to 3 sig figs. Looks like exactly the same value. Whether or not you write down this kind of notation on a paper 2 is up to you. If you do write down this kind of notation or give some evidence of p and 1 minus p and combinations, you'll get a method mark. Writing this down is probably worth M1A1, where this will be the 3rd mark. If you just jump right to the GDC and just with confidence put down this kind of thing, ... and then round it to 0.2293, you'll pick up an N3 for full marks on that. But have a think about possibly making visible some of your methodology and some of your thinking. So let's talk about that CDF feature now, because it really will take and reduce time-wise what would be a fantastic amount of work. And of course, you don't have that many minutes during a paper 2 to produce that much method. So what about of those 5 students randomly sampled, at least 3 students are in favor of eliminating final exams? Well, if I come down here and say that I'm at least 3, that means 3 or more in the context of 3, 4, or 5. So if the random variable, once again, is defined as the number of students in favor of eliminating exams, and you're trying to find the probability that at least 3 are in favor, that looks like this notationally, which really just means, again, 3, 4, and 5 respectively. Add them up. So what I've done for you here to sort of reiterate the PDF function, I've said, well, looking at the likelihood of exactly 3, that's the one that we just did a second ago. The likelihood that 4 are in favor of actually eliminating exams looks like this here. So here's 3, 4, and 5 respectively, and if you added those up, and round that to 3 sig figs, that's a valid answer. However, the GDC will take care of this for you in seconds. You're back to second VAERS to get the distribution. You grab the binomial CDF. Notice that it's CDF here. And so you're putting in n of 5 trials. It's still 0.72 for the likelihood of success. And I put in an x value of 2. Why 2? This is a left to right feature. So in a cumulative sense, if I come down here, once again, the probability that the random variable is 3 or more, which we've seen clearly over here, is actually 1 minus the likelihood of 2 or fewer, right? So that's just the complement to this here. This CDF feature is a left to right feature. What do I mean by that? It means it accumulates 0, 1, and 2 respectively. So it works from left to right. So when you put in 2 here, in a cumulative sense, it's giving you everything from 0 through to 1 and up to and inclusive of 2. So again, when you hit enter on that, paste it back to the home screen, we're talking CDF here. You see this representational view as a way of just reflecting this input here. You get 0.138-ish, if you will. And then 1 minus that is the complement, and it's exactly the same answer as you see over here. So again, this CDF feature works from left to right. So in a cumulative sense, it gives you everything from 0 up through and inclusive of what value you put in there. I hope that makes sense.